Have you ever wondered why this MCP exists and how this LLM fits in this picture of MCP? So if we really want to understand this, we have to go through the history of AI revolution. So let's unwind our clock and let's go to 2019. At 2019, the world got to know a word that is called as LLM, large language model. So what AI researchers and ML engineers did is they basically use books, Wikipedia, research papers, blogs, programming code, documentation, scientific articles, and they use this to basically train the LLM model. So the first question that arises in my mind is, what is this LLM? So LLM are basically text generators or token generators. So what I mean by that is, let's say you are giving a input to a LLM model. So what it will do is it will first generate a token, and that token will be a single token. So a single token basically means a single word. Then after that, at next iteration it will generate another token. Then at next iteration it will generate another token. Then at next iteration it will generate another token, and this way it will actually able to generate the whole sentence. So let's see with an example. So as you can see in my screen, let's say a user asked what is the weather in Delhi today, and the user asked to a LLM model. Now what the LLM will do is it will first generate a token or a word. So that word you can see in the output is today. Now in the next iteration, what it will do is it will take it as input and it will put it to LLM, and then the next output will be generated, that is called as weather. So the whole input becomes today weather. Now the input becomes today weather, and then at the next iteration it will be given to LLM, and then the next token that is generated is. So the whole input now become is today weather is. So I just want to emphasize on this that LLM works on a principle of next token prediction, and even today LLM are only able to generate a single token or a single word with each iteration, and then with each iteration it is able to generate 111 token, and then it will able to generate, like with multiple iterations it will able to generate the whole sentence. So this algorithm is called as next token prediction, and there is one more word for it. It is also called as auto regressive generation. So if you come up with a word like next token prediction or auto regressive generation, both are exactly the same. Now the next iteration, today weather is given to LLM, and this LLM model is of 2019, and now the LLM model got confused. Like it doesn't know what is the output, it doesn't know whether it is hot or cold or cloudy, whatever it is. So now the output is today weather is, and after that it doesn't know. So why it happened at 2019 is because at that time, if someone asked this to a LLM model, LLM model doesn't have a real-time knowledge at that time at 2019, because they are not able to call any external systems. Like they are not able to call internet or any file system or GitHub or database or any weather API in our case, or any Slack. So they don't have the capability to call to any external system. So that is the problem at that time. So now what there are many researchers, there are many engineers, they are doing the brainstorming, and then they wanted to give LLM a capability to call to external systems. So there is an evolution that comes here, and that evolution is of tool calling, and this breakthrough of calling to external systems came at actually 2023. So let's go in an era of 2023. So let's say now we are at 2023 and we have a capability of tool calling. Tool calling means you can call to a external system, and with each external system is called as a tool, right? So let's say at that time, now our user asks, what is the weather in Delhi today? So the LLM will start thinking about it. Okay, this is the context the user has asked, and now it knows, okay, I don't know the weather data, right? So what it will do is it wanted to call the weather API, that is the external system, and it wanted to call the weather API with a parameter like city is equals to Delhi. So what it will do is The LLM model at 2023 will call to a tool bridge. Tool bridge is basically a middleware, like it's a bridge between the external system and your LLM. And then from that, it will able to get the data of the weather. And now the weather data is basically city Delhi, condition is cloudy, temperature is 34 degrees Celsius. Now, after that, once the LLM has the data, LLM will generate one token at a time. Like, so it will generate the first token, that is today's, then generate the next token, that is weather, then is, and then similarly it will generate further tokens, and the whole sentence will become today's weather is cloudy with a temperature of 34 degrees Celsius. So this breakthrough happened at 2023. Now from 2023 to late 2024, that is November 2024, what people have started doing is, let's say, as you can see in my screen, they have apps like Cursor, Claude, or some internal AI assistant where there is a chat UI and they have a LLM built in. Now whenever they want to call to any external system, they have developed their own custom tool layer. As you can see in my screen, in Cursor I have a custom tool layer which is actually calling to GitHub, file system and terminal. Now in the next AI application, that is Claude, I have another custom tool layer which is specifically for Claude, which is used to call to file system, Slack or database. And there are some other internal AI assistant, maybe some company have developed it, so they have written their own custom tool layer. So from 2023 to November 2024, it become a mess, because everybody, when they have a AI application, they need to write their own custom tool layer, and that is exactly a very big problem. So now the researchers and engineers have started their brainstorming, and at November 2024 they have actually come up with the idea of MCP server. So MCP server is actually a middleware between your AI application and external system, but you don't need to implement the custom layer for each AI application. It is basically the MCP server is based on a standard MCP protocol, and your AI application has to follow that protocol. So now you can see in my screen, from 2024 November to present, the AI application, let's say Cursor, Cloud AI or some internal AI assistants, they have removed their custom tool layer and now they are basically using MCP server, which is basically a single hub for every client, and all the AI applications can connect to that MCP server, and the MCP server will connect to basically external systems like GitHub, file system, terminal, Slack, database or anything. Now you basically understand why we really need a MCP server, because MCP server actually help so that you will not implement a custom tool layer for each AI application, and you just have to write a MCP server based on MCP protocol, and every AI application, either it is Cursor, Cloud or anything, it can basically use that MCP server to call to external systems. Now this is basically the very uh, above overview of what we are seeing, but now I wanted to deep dive a little bit, and I wanted to tell you like how really the request cycle works. What I mean by request life cycle is basically that, let's say there is a user, there is an app has LLM built in, so and there is a MCP server. So if we see things in detail, what is the exact life cycle? So now as you can see it here, we have a user. The app can be anything. The app can be Cursor, Cloud or any internal AI assistant. The LLM is basically the LLM which is present inside the app, right? So if you have used Cloud or Cursor, they have LLM built in that app. So LLM is that, and MCP server is basically a server which can be hosted anywhere in the internet, and beyond that MCP server there are external systems. So how the flow is, whenever a AI app initializes a connection with your MCP server, it first asks like what are the tools that you have. I mean, what are the external systems that you can call. Each tool is basically, you can think like each tool you can map to an external system. Like a tool you can map to a Slack, post something in Slack. You have another tool where you can raise a PR. You have another tool where you can query a database. So you can think like that. Now after this initialization of the connection, your app knows what are the tools I have. Now the next thing at this request lifecycle is user throws a query, right? Let's say user has written something in the UI like, can you help me, like what is the weather for the Delhi today, like the same example, right? Now what your app will do, your app will basically sends this query to your LLM, right? And your LLM will respond to like which tool you need to invoke. So in our case, let's say if a user has asked for weather API, the LLM will respond like, you basically have to invoke a tool which will basically get the weather data. Now after this, the application actually sends a tool call to your MCP server, and it sends like, just invoke this weather API for the city Delhi, and then your MCP server will call that external API and it will respond back with the tool response like, okay, this is the weather data that we have seen earlier. And then once the response came back, the app again send the response to LLM so that you give me the final answer, like you just take this and just make it pretty, right? And after that LLM generates the final answer, and then your application generates that final answer to you. So this is exactly the full flow, and from this example it has become pretty much clear, like whenever a user interact with any application, that is cursor Claude, how the LLM actually fits in between. It is actually something that is present inside that AI application, and the application logic and the LLM together connect with MCP server, invoke a tool, get the data, and then basically they respond to a user. So now I hope like you have understand it, and let's say if you have any doubts regarding it, you can reach out to me in comments. Thank you for supporting DeeperBits. Thanks a lot.